you because we did something in math for some of these that I'm not allowed to do. I divided by 0. Right? I don't know what x is, right? So x could be anything, right?
No.
I don't know what x, for example, the answer you guys put on the whiteboard for this one was this, right? Oh, yeah. Here we go. Is this, right? I don't know what x is, right? That's the whole point of using an x. I can say it can be anything, right? But can it be anything in this case? Some of you are saying no.
Yes.
Okay, what are you thinking?
Anything but 0.
It can't be anything but 0?
No.
Josh?
It can't be anything but -3.
It can't be -3 because -3
Wait, what? Oh, because it equals 0.
is the root of the bottom, right? That's called an excluded value. Now hold on. I want you to try on your calculators 0 divided by 0.
Error divided by 0, right? Error. Error. It's a divide by
So that's a problem. So the 0 divided by 0 also would have caused a problem, correct? So there's actually another excluded value on part F.
0.
And you take a look, not at me, at your papers, okay? There's one more excluded value that would create a 0 divided by 0 error on F. It's not 0. It's not 3. Josh got the other one. I'm not going to let him do this one. You guys, come on. You're all so smart. This is almost college level math. You're doing good. Okay? What is it? What? So the -3 would make a divide by 0 error, right? But 0 over 0 is also an error. So what is my excluded value that would be the 0 over 0? Caden?
3.
Nope. Good guess.
Just be 1/2.
Nope.
1/3.
Nope. Nope. Daniel. Oh, so close. But it absolutely, Daniel, so good, comes from this factor, the 0 over 0 factor.
Oh.
But what's the root for that factor?
2.
The opposite, 2. Good.
Wait.
So here's the problem, you guys. I can't divide by 0, not just at the end, I can never do it. Okay? So excluded values make the denominator 0 anywhere in the process. Does that make sense? You with me?
Yeah.
So do I look for excluded values before I reduce or after I reduce? Before. Very good. Before. Okay? Very good. Let's go back here. And I guess I actually should call number 4, not number 4, but number 2.5. Because, well, Jacob told me, right? Where do I look for excluded values? Before I cancel, before I reduce, right? Find, well, I didn't think of it. Find excluded values. So that would be the roots of denominator excluded. Roots of denominator before you reduce.
that question was wrong?
It's right as soon as I put my excluded values there.
Because you just have to say X is not.
Because if there's no excluded values, then, here, I'll take it. If there's no excluded values, then, or like written, then I'm assuming it works for any X. Which when we applied this stuff to learn, like combine this algebra unit with last unit and we graph these bad boys next unit, that's going to affect the domain. There's a scary word, right? And we'll apply it to that. Does that make sense?
It's not infinite to infinite anymore.
It's not infinite to infinite anymore. There we go. Okay.
That was the easiest question on there because it was always that.
Okay, now let's go here. I want us to double check what we did on A. Should we have had an excluded value?
No.
Is there a possibility of a divide by zero error anywhere in my process?
Yes.
Yes, there is an excluded value. What's the root of x squared?
X.
Ooh. Nope. What's the root? What's the zero of x squared? What number do I plug in for x to get zero out?
0.
Zero.
Ah.
So it's a 0.
X cannot be zero.
And this one X cannot be 1.
Whoa, wait a minute.
Ew.
On C, Caden said x can't be 1. Because there's a 1 on top?
No, because X minus
Because
1
it's
is
X
X minus 1.
There we go.
Stupid.
Josh is too good at this.
Seriously.
What about E? What are the excluded value or values on E? Not Caden, he answered the last one.
3.
Go ahead. 3? What about 0?
No, yes. Yep.
Is 0 an excluded value?
Yes.
Yes.
No.
0 is a root for the numerator. I can have 0 in the top of a fraction, just not the bottom of a fraction, right?
But wouldn't that make it 0 still? If it's on the top?
Which is allowed. That's a number I can graph.
We're not allowed.
0 over 0 is the problem.
Wait, 0 to left, you think you can graph that?
0. Where's 0 on the coordinate plane? Origin.
Sorry, I'm dumb.
You're not dumb. That's like the most confusing part for these, okay? All right.
Okay, on top.
What about G?
Wait, it can't be 3. Oh my god,
Oh, no, you're not. Stop calling yourselves dumb.
I didn't know.
But that's exactly
No,
how they
I'm not calling on Josh or Kaden unless it's a question.
Because they're smart.
Yeah, because they're the only ones answering, and I know more of you can get these questions right. Sydney,
I
Can't be 4.
very good.
She's smart too.
I'm doing a better job today than I have in the past of making sure more people are participating because you're all capable. What about
Sounds like.
H?
What-
Any excluded values on H?
3 and 0.
No, 0.
Not 0, only 3.
Only 0 is just one.
Okay, here's what I want you to do for the next little bit is we'll walk around and help, but I want you to try start to finish I, J, and L. They all are a little bit different in their factoring. So I, J, and L. So GCF, factor, excluded values, reduce. Yeah.
Is there always going to be an excluded value?
That's a good question. No, there is not. Because if our excluded value ends up being, so if the only x on the denominator ends up giving me imaginary roots,
So what do you divide on?
non-graphable ones, they don't affect the domain, right? Remember we talked about that last unit? So if my only excluded values are imaginary, then there are none, and we would just say no excluded values.
Are we doing A?
Okay, huh? No, K is the same as J. I don't think you need 2 of them. So I, J, and L, okay?